Hey everyone, we are on page 375 and we are going to just do half of chapter 42, our last chapter, and we're going to end this ecology unit talking about ecosystems and the flow of energy through ecosystems and then the cycling of chemicals. And so today for this ed puzzle, you're only going to talk about the flow of energy. And as I go through this information, you're probably going to think to yourself, she's already talked about this before. And you're right. There's a couple of new things I'm going to introduce, but really this is more for completion's sake and for you to see that energy flows and chemicals cycle through ecosystems, and that is how the abiotic and the biotic factors work together. So that's why we go back over some of that information. All right. So the first thing to know is the definition of an ecosystem. It is the sum of all the organisms living within its boundaries and the abiotic factors with which they interact. So you're going to have your populations, right? And then your populations are going to make up communities, and then communities with abiotic factors are going to make up the entire ecosystem. All right, so pause the video if you need to write that down. Our focus in this chapter is two things. We have two focuses. The first one is energy flow, and the second one is chemical cycling. And so energy flow has to do with food, basically. And chemical cycling is going to have to do with water, nitrogen, carbon, and phosphorus. So we're going to talk about those four biogeochemical cycles. But like I said, for this ed puzzle, we're only going to focus on energy flow. Okay, so you have this beautiful picture right here. And what I want you to notice is the very starting point is the sun. The sun provides a constant input of energy. The primary producers are going to perform photosynthesis. Primary consumers are going to consume primary producers. Secondary and tertiary consumers are going to consume primary consumers. Y'all already knew that. The new thing that I'm introducing here in this picture is this word detritus. Detritus means dead organic matter. So it's basically like dead plants, dead animals, dead things. So things that are no longer living and they're organic matter. So it means that they at one point were living, but they no longer are. And so all of these things, your producers and your consumers, are all at some point in time going to become detritus. So what happens to detritus is that it gets consumed by microorganisms and other detrivores. And so the word that I need you to write down for the microorganisms, those are your decomposers. And you're like, wait, decomposers and detrivores, what's the difference? Well, a decomposer is going to directly decompose the organic matter in the soil and provide it directly like to the soil to like help nourish plants. A detrivore is still going to consume detritus, but it's not like a direct thing that happens in the soil. So let me give you an example. So bacteria that lives in the soil would be a decomposer. A vulture that's waiting on like a post somewhere sees a deer get hit by a car. I know this is awful, but this vulture sees a deer getting hit by a car and it swoops down and starts, you know what they do, doing its thing. That would be a detrivore. So you kind of see what I'm talking about there. It's not living in the soil, breaking down dead matter in the soil. It would be a decomposer. If it's not that, then it's a detrivore. Yay. All right. Energy cannot be recycled. It just can't. It must constantly be supplied by the sun. All right. So energy cannot be recycled. So get that written down. The autotrophs are your primary producers. We consider them to be self-feeders. They're going to be photosynthetic. We always think of plants when we think of photosynthesis, but is algae, the green algae, like you see in one of the fish tanks I have in the classroom. I have a lot of green algae growing in there. Green algae does photosynthesis, but it's not a plant. Green algae is a protist. It's a eukaryote, but it's not a multicellular eukaryote. They're single-celled eukaryotes. All right, so when you got that down, click. The autotrophs are going to use light energy to synthesize sugars and other organic compounds. So we had a whole chapter on that. Photosynthesis. Heterotrophs or other feeders can't make their own food, so they're going to feed on the producers. All right, so once you got that down, we're going to, so write down heterotrophs in that blank. We're going to flip to page 376 and look at another diagram. I'm basically restating. This is the same diagram that's on page 375, but it's just a little bit, I think it's a little more organized and it's more like square shaped. You start with the sun on the bottom, it goes to primary producers, that goes to primary consumers, that goes to secondary consumers, detritus, decomposers, and detrivores. All right, so this is the flow of energy. And then the microorganisms and detrivores are going to provide nutrients way back over to the primary producers. This, guys, is called the circle of life, and it's beautiful. I want you to notice the red dotted lines or the hot pink dotted lines, whatever color you want to call that. It's showing you just a lot of heat release. And so when we've said in the last chapter, and we're going to say it again a few times in this chapter, that movement through trophic levels is very inefficient, and that 10% rule that we discussed last time, that comes into play here because so much energy gets lost as heat. And so this picture is showing you the flow of energy, but it's also showing you how, like, just at every step of the way, a lot of that energy is getting lost as heat. Okay? Heterotrophs are the trophic level above primary producers and depend on their photosynthetic output. And then we're going to go over a bunch of easy information that you pretty much already knew. Herbivores eat primary producers, and they are called the primary consumers. Carnivores eat herbivores, and they're called the secondary consumers. Carnivores that eat secondary consumers are called tertiary consumers. And click. Come on, clicker. Hold on a second. Why is that not working? Okay, this thing is really annoying. What is it doing? You know, I would edit this video after this happening, but I'm just like not. There we go. See, it's just like we're in class and I'm having tech issues, like old times. All right, another important group of heterotrophs is the detrivore and decomposers. We've already talked about that. They get energy from detritus, non-living organic material, and they play an important role in material cycling. Okay, so that just really sums up that last picture, sums up everything that we just talked about. That is the flow of energy through ecosystem. So pause if you haven't got that down because I'm about to click. Pause. All right, I'm clicking. I'm going to do it. Your main decomposers are fungi and prokaryotes. And they're going to be near the soil. They're going to be like almost in the soil. And so they decompose because they're decomposing it basically in the ground. All right, so you're going to write that down on the bottom of 376, fungi and prokaryotes. I want to talk a little bit about primary production. So your producers, they make something called primary production. The amount of light energy that is converted to chemical energy through the process of photosynthesis. Gross primary production is the total primary production in an ecosystem. So this is the total amount of glucose that all the plants in that ecosystem and all the algae make, okay? All of it. Your net primary production is always going to be less than gross primary production. If you take an econ, this can kind of relate to money. Gross primary production minus the energy that the living organism is actually using for respiration and other cellular processes. That gives you your net primary production. So here's how I think of it. If I'm running a business, let's say I'm selling something like honey flavored soda, and I make $1 million in 1 year. That's like my gross income, right? The gross amount of money that I make. Am I really making that? No, I then have to factor in, well, I had to pay for honey, I had to pay for like a way to carbonate the drink, had to pay for the bottles, had to get a booth at the farmer's market, stuff like that. I have to subtract that from my gross amount. That would give me my net amount, which would then be my profit. So that's kind of how this works. So then you need to know NPP equals GPP minus R. That would be on your formula sheet. Just remember, if you ever see anything on the AP exam about primary production, just go to the formula sheet. Anytime you see anything on the AP exam that you don't know, you're like, what is this? I've never seen this. Just go to the formula sheet and I bet it might be there. So the NPP, the net profit, the net primary production, is the storage of chemical energy that is then available to the consumer. All right, so you have a cow that's grazing a field. The net primary production from the grass is what's available to the cow. All right, it's not everything that plant makes because the plant uses some of it for itself. Hopefully that was clear. All right, pause if you need to because I'm about to click. Boop, there we go. Okay, this picture is not on your notes, but I'm still going to talk about it. That's a lot of stuff. So if you look on the left side, you're like, oh, cool, open ocean, estuary. Oops, tropical rainforest and savanna, I know what those are. Temperate grassland, tundra, forests. All right, these are biomes on the left side. All right, so you have all your biomes that cover the earth. The first little table thing here, graph thing, this is a bar graph, obviously, is the percentage of Earth's surface area that's covered by that biome. And you'll look and you're like, dang, the open ocean covers a lot of Earth. You're like, yep, I've seen a globe before. I've seen a map. That's actually right. Most of the Earth is covered by ocean. Cool. B, this graph right here, your average net primary production grams meters squared per year. So what this is telling you is efficiency per unit area. Per unit area, how much photosynthesis is occurring? Well, it's kind of interesting to look. The open ocean now isn't that efficient when it comes to photosynthesis. Why is that? Why is that? Sophia, what do you think? What do you think? Yep, you're right. It's because the sun cannot penetrate through all that water. But there are some places that are shallow enough where it can, so there is a little bit of production. But since the ocean does cover so much Earth, it's not efficient, but it will still make 24% of Earth's primary production overall. All right, so that's one thing I wanted to point out. The other thing I want to point out is the tropical rainforest. 3.3% of the Earth's surface is covered by tropical rainforest, but look, look how efficient it is. And you're like, yep, I have seen pictures of the tropical rainforest and it is green and it is warm and it is wet and there's so much photosynthesis happening. Makes sense that it's the most efficient. The 3.3% that the tropical rainforest covers is still going to equal the same percent of Earth's net primary production that the ocean does because it's so efficient. So that's all I really wanted y'all to notice. When you take your AP exam and even when you take your quiz in this class, I'm really trying to get you guys in the practice of reading graphs. And so that's just something that I'd need you to be able to do is to look at, well, what covers the most, what ends up making the most, what covers the least, but still also makes the most. Why is that? Because it's more efficient per unit area. Cool. All right, now we're back to the notes. Primary production is affected by light availability, nutrient availability, N equals nitrogen, P equals phosphorus, and temperature and moisture. Okay, so primary production is affected by light availability. The deeper you go in the ocean, the less photosynthesis is going to occur. But you didn't know that. All right, and then nutrient availability. In marine environments, you got to have nitrogen and phosphorus. in any environment you do, but that it's more challenging in marine environments, which is why we talked about before it's less efficient in marine environments. And then key factors controlling primary production, temperature and moisture. I mean, we know that, right? Right, so make sure you got those down. Pause if you need to. Okay, energy transfer between trophic levels is 10%. We've already talked about this. It's only 10% efficient. This picture right here is just showing you part of the reason why. So you have a caterpillar that's eating a leaf. It's getting 200 joules of energy from that leaf. Half of that is leaving as feces. Oh my God, that's so weird. Like why? Like why doesn't it just use it? It's so inefficient, but it is what it is. Those feces are going to go back into the earth and it's going to help grow more plants. So that's cool. 67 joules is used for cellular respiration for that organism. All right. And then only 33 joules are actually going to be used for secondary growth. So right there, you have about 16%, 16, 17% being used for the caterpillar. And then this isn't accounting for how much is given off as heat. So when a bird comes and eats that caterpillar, it's only going to get 10%. Kind of like in this situation, there's not very much energy that's being used. And that can range, like the 10% thing is an average. It can range 5 to 20, depending on the organism. So production efficiency is only a fraction of the energy that's stored in food. So production efficiency for this caterpillar eating this leaf would be about 17%. And then when the caterpillar gets eaten by the bird, it's about, it averages 10%. So don't get confused by this being 17%. You're like, I thought you said it was 10%. It ranges 5 to 20 with an average being like 10, okay? So we are going to use 10%, but this example is giving you 17, but just so you know that is kind of confusing. So a lot of energy is used in respiration and is lost as heat. Energy flows, it doesn't cycle, and there's a constant input of the sun. We've already talked about that. Okay, so if you can please pause the video, make sure you get those things written down. Definitely is important that you know why is it 10%? Well, if I asked you, why is it 10%? You would need to be able to tell me half of it leaves as feces, half of it leaves as waste, and then another chunk is used for cellular respiration, is given off as heat. You need to be able to tell me that. Okay, so pause if you need to. I'm going to click. This picture right here is just showing you an example of the 10% rule. We've done an example like this in class. 1 million joules of sunlight. The primary producer only gets 10,000 of that. The primary consumer only gets 1,000. The secondary consumer gets 100, and the tertiary consumer gets 10. So this is just showing you a 10% transfer as you go up trophic levels. And it's showing you how the tertiary consumer just really doesn't get that much. And so ecological pyramids, that's what these are called. It can give insight into food chains and food webs. And so the loss of energy as you move up is going to limit the number of top level carnivores. And so most of the time when you see a food web, you're only going to have 4 or 5 trophic levels. Okay, so I would just write down next to these pictures like limits the number of carnivores. You would never go over 4 or 5. So I'd be willing to bet if you looked at your food web that you're putting in your project, that you're not going to be able to go over tertiary or quaternary. You're not going to be able to find more than that over that. All right, so pause if you need to. Now moving on. Last thing I want to say is that the dynamics of energy through an ecosystem can have important implications for the human population. And I'm not preaching to you guys, but it is part of the curriculum for me to tell you. Why are we eating cows that are eating plants when we could just eat plants? Why are we up here when we can be down here? You know, when I talk about carrying capacity, and what's the carrying capacity of Earth? Is it 10 billion? Is it 15 billion? Is it 20 billion? What's going to determine that is how we use our resources and how we conserve our resources. And at some point in time, we all may start to think, let's try being vegetarian. Let's try those plant-based chicken nuggets that we found in the freezer section by accident 2 weeks ago at HEB. You know, my daughter really liked them. I don't know if I told you this story. I told it to the other class. I accidentally bought plant-based chicken nuggets, and one of my kids, like, she ate the whole bag. It was crazy. All right, I'm over my 20 minutes now. Hopefully you got those notes taken down because your quiz is going to be open note. Next time I see you, which will be Wednesday morning, we will finish up this chapter, and then you'll take a quiz on Friday after we do some review games. All right, I'll talk to y'all later.